Okay, so this homework is the multiple regression homework, which turns out to be hierarchical regression. And multiple regression is when we are looking at a model, and hierarchical regression is when we are comparing two models. And so our boss believes the best predictor of performance will be oral expression and oral comprehension tests. And so you're running a regression to show that these two predict job performance. But you also believe written expression and written comprehension are important. So you decide to add a model to the regression to determine whether written comprehension and written expression account for variance and overall performance above and beyond the oral communication variables. And
So I
this,
have a question there, just so I can
yes,
get. This is what I want to get straight in my head. So when we're talking. I get that we're talking. I mean, I totally get what we're doing here for once, but when we're talking about the first model is oral comprehension and expression.
yes,
Is
correct.
the second model written comprehension and expression, or is the second model written and oral comprehension and expression? So there's four components to the second model, or are there two to each?
Well, actually, I think the way that we talk about it first is that they're two to each. We're adding two, but when you look at the SPS output, there's when you add anything in the second model, it adds it to the first one. So there will be four variables in the second model. So in
So the
general,
second, so the second model, okay, I'm not running. At no point am I running just written by itself. So the second model does include all four.
yes, it includes all four, and your adjusted R square, I'm sorry, not
Okay.
your adjusted, your change in R square tells you the effect of just the two written tests.
Okay. So
So,
that's what it would be if I ran them alone too.
yeah, and this is a great question, and this is what's confusing. Um, but what I wanted to say is the key here is when you see the words account for variance above and beyond, or you see does this have incremental variance? Those words indicate that you need to do a hierarchical regression and that you have more than one model.
Okay.
Another thing would be that if it said you needed to hold some variables constant, that
Okay.
would be your first model. That would also indicate that you have two models. So just want to talk
Okay.
about the wording so that when you see a case study or another problem, you understand when you're doing multiple regression. So if I said I want to know if these four tests predict job performance, I would just be doing a multiple regression. But when we start talking about blocks and that we're looking for does something add incremental or account for variance above and beyond, now we're talking about hierarchical regression.
Okay. All right. So I'm starting with two and then adding two instead of starting with four.
Yeah, you start with two, you're adding two, which means your second model is going to have four.
Okay.
And I'll say a bit more about that when we get to the SPS output.
Okay.
I just wanted to go over the wording and let you know why we know we're running what we're running so that you're more comfortable in the case study making that judgment.
Okay.
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 So then here's my test validation file, and I'm going to go to analyze, regression, linear. Now my dependent is overall performance, which I believe is right here at the end. And then my first two, I'm not sure where these are. I'm going to open up my window so I can see. Okay, here we go. Their ordinal, okay, so I'm going to do oral comprehension and oral expression. Those are my predictors for block 1, and you can see block 1 of 1's up here. My method is enter. And to get to the next block, I want to hit next. Now it says block 2 of 2. I'm going to add written comprehension and written expression, leaving it at enter. And then in my statistics, we always want to do the confidence intervals, but we definitely here want to do R-square change. That's the big difference in hierarchical regression. We want to see the R-square change.
Oh, so you didn't even, so I ran first the regression with the first 2. You don't even have to do that.
No, because remember,
Okay.
the first block is that regression that she's asking for.
I see. Got it. Okay.
Okay. I'm also going to hit descriptives. I think that's all I need. Okay. So my descriptives come up. That's going to be important for the correlation table. My correlations. Now, this is different than the correlation matrix we ran earlier. If you find it too difficult to read, you can just run a correlation matrix with these 4 variables. But these are your p-values. So you can actually double click and select this, and it's easier to put in, and then you can do it to 2 decimal points. And these are your p-values, so everything's significant at the 0.001 level. Here is the summary of your model. Model 1 has the 2 oral components. Model 2 has the written. We use the inner method. So here are the model statistics. Model 1 accounts for 65% of the variance. Right here, the 647. That's a large number. We know it's significant, but where do we get the numbers? We come down here to model 1. Our F and our p-value tell you it's significant. We get our degrees of freedom here, 2 and 264. Our second model is significant. It is 70%. I'm getting right here. How do we know that's significant? We go down and look here. Our F. I notice here our F went down because we added variables, so we're losing power, even though our F is still quite large. Here's our degrees of freedom. Now, our change in R square, which tells us what the 2 written components are adding by themselves, is 6% here. This is our F, our degrees of freedom, and our p-value. So model 1 tells us the percent of variance that the oral components give us, which is 65. Model 2 tells us the percent of variance that all 4 give us, which is 70. And the difference between that is 6. There's some rounding errors here, but don't worry about that. Just always round to 2 decimal points. I'm going to mute somebody. I'm going to hear some typing. Okay. I'll take the mute off in a second. Okay, so I think I was saying model 2 tells us the percent of variance for all 4. R squared change tells us what the ones that were just added, what are they contributing? So right away, I can see adding 2 tests, which is doubling the cost of your selection system for 6% is not great, especially when my first 2 tests are at 65%. I mean, that's outstanding. I would stick with that. But further, we're going to analyze the individual variables. So, and when we do that, we typically only look at the second block. But now your boss was asking about the first block. She was saying, hey, run a regression. So this would be your multiple regression. So that is what she's asking for. But when you add in the other two, this is how it changes, and this is what you'll be reporting. Now, if you want the practice, you could report this as a multiple regression and then this as a hierarchical regression. And here we see that all of our predictors are significant. And we look here at the standardized beta weight to see what order of importance they're in. And this is the strongest, the next strongest, the next strongest. And these two aren't too far apart. And then you have the written expression, which is not much. But what's interesting to note is here how high oral comprehension is and oral expression. They're higher than anything here. And so what's happened is we've added variables that that have shared variance with these first two. So we're taking away from these first two and we're spreading it out between these tests. But these are stronger on their own. So it doesn't necessarily make for a better model. Okay. So then we're going to report, you can report either the unstandardized or the standardized beta weight. The T, the degrees of freedom is going to come from this residual in the second model, 262. Your P and your confidence intervals. And as I mentioned in class, with 4 significant variables, you want to make those more indented bullets when you talk about each of those. Don't put all 4 in a paragraph together. That would be really jumbled looking. And second, put your confidence interval in the table, add that to your beta weight table, and then instead of writing this text 4 times, which would be very repetitive and not very helpful in the text, you can say a sentence such as, we can be 95% confident that we would see beta weights in the future, beta weights that look like these in the future. Please see table 2. And then you would have your, then you would have your confidence intervals in the table. And then you don't have to write out that lengthy sentence 4 times. So the next thing that I want to do is write this up and look at the tables. So again, the easiest thing is to take my write-up and change it. Okay. Okay. So down here, I'm going to put the write-up. I'll take this out and you can write your own narrative. In Model 1, oral expression and oral comprehension were the predictors and overall performance was the criterion. This statement could also go in the introduction. I'm just putting it all here. Model 1 was significant. Now what I want to do is put this where I can see Model 1 was significant, and that's 65. My F is 264. 264. The F value equals 24226. P-value the same. Model 2. And you need to state what was in Model 2, which added written expression and comprehension as predictors, was significant. R squared equals 0.70. F equals, well, the degrees of freedom are 4 and 262. And my F value is 15426. When controlling for oral tests, the 2 written tests still predicted overall performance. R squared change, 0.06. Move this down a bit. 262. F value is 24.02. Okay. And then Model 1 accounted for 65% of the variance. Model 2 accounted for 70%. And the change between the models was significant at 6% of employee overall performance. Okay, now we're talking about, and if I were editing this, and I might even move the percent of variance to line up with each thing instead of saying it all at the end again. Okay, in this, whoops. In the second model, I'm going to say all 4 variables were significant predictors of overall performance. And here's where I would, indent your bullets. And you want to write something about each variable. I'm going to write something about the first one. You want to remove this. You do not need a scatter plot. So for the first one, and I'm going to go in order of importance. So I'm going to say the strongest predictor was oral comprehension. And I'm getting that it's the strongest from this 346. It's the largest standardized beta coefficient. And B equals 0.21. My degrees of freedom is 262. The t-value is 7.14. Whoops. And it's less than 0.001. Please see table 2, your hierarchical regression beta weight table. Okay, so you're going to repeat that for each variable in the order of importance. And then you're going to do your regression equation. And the dependent variable is predicted overall performance. Now my constant I get right here, 1.118. And remember, we use all 3 decimal points in the equation only. 1.118 plus 0.205, and that is times the independent variable of oral comprehension. Oops, let me capitalize that. And these are all going to be positive, so it's all going to be a plus. Plus 1.74, and this one is oral expression. Plus 0.167, and this variable is written comprehension, plus 0.085 written expression. Okay, so that is your equation. And then you want to write your recommendations. And again, I've given you a big hint on it's financially probably not worth it to add these 2 tests. And if we were to go back and look at, and let's just do that right now, look at our correlations. These tests are all highly correlated with each other. So it makes sense just to use the strongest ones. And the initial 0 order correlation, the strongest one is oral comprehension and written comprehension. And so you don't know which ones are sharing, you don't know how they're doing shared variance. You would have to look at the part and partial correlations. And the other thing that you could do, and I'll do this really quickly, is look at the collinearity diagnostics. Say okay, it's going to run this again. Okay. And none of these actually look too bad. I guess these two are kind of closest to 1, but they're still pretty far off, and none of these are close to 9 or 10. So you could possibly look at combining one of the other ones, but these two certainly do a great job. So possibly rerun your regression, and I'm not saying do this for homework, but in real life, rerun this regression, look at oral comprehension and the written comprehension, and see if that has a better R-square value, the two of those together, than these two, still sticking to 2 tests. So that's what I would think about it. Now, after you've done your write-up, you're going to enter your variable names here. So let's say, whoops, actually you would probably go in order. Oral comprehension. Put the mean here, the standard deviation, and then 1 is going to be 1 because your oral comprehension variable is listed as 1. And then however you list them, that will be what goes, you don't need to write the variable name here again. You can just use the shorthand of using the number. So you're going to fill that in. You're going to remember to only fill in either the bottom half or the top half of the triangle. And you're going to make sure it's 2 decimal points and flag it if it's significant. They're all significant. So you're going to change that to 0.001 and flag them all. And then here, you're going to list your variables. And this is your little b, and this is your standard error, and this is your big B. And so, again, if change this, because you do have to, I would remove the R square. You do have to flag your significant variables, and I believe they're all at 0.01. And then shrink these columns. I would insert tables. I would insert another column. I can't find it in this smaller version, but I would insert another column and make your confidence interval columns right there, and that'll save you some space. And so those are the 2 tables that you are going to fill out for this homework. Now, let me take the mute off and see if there are any questions.
My question was, I think I ran it first. I think I ran them backwards. And so all the numbers in Model 2 are the same, but it changes the R squared. I didn't do that, right?
Well, yeah, it does change the R square. So if you put in written first, you'll get different results.
So order matters a lot.
It does.
Okay, got it.
And Bruce, let me just speak to why that is. Because these tests are highly correlated, whichever ones you put in first are going to grab up all the variance.
Okay.
So.
All right.
Natasha?
Oh, yeah. So for table 2, you said include the confidence intervals. Do we also need to include the p-values, the significance, or no? We could just leave that out.
Yeah, great question, Natasha. You actually do not have a p-value column in this APA table. You just flag it. Similar to the correlation table, you just flag it with an asterisk or a star.
Okay, so we don't have to, we just do that we just add the asterisk on the betas.
Yeah, it's either this or I think it might be the standardized betas where you're supposed to put the flag.
Okay, because I included like my p-values, but I wasn't sure. Like I added another column for p as well as the confidence intervals, but I didn't know if that's necessary or we could just delete that, like the p column.
Yeah, delete your p-value column.
Okay.
Any other questions?
No.
All right.
Thank you
for coming. I'm gonna stop the